Oh, baby, look at that. This is what I'm calling my pocket computer. It's a Raspberry Pi with this e-ink display, this full function keyboard that's really tiny. It's got USB-C charging for this huge battery in the back. This thing took me way longer than I thought it would to make, but I learned a bunch and I can show you what I learned along the way. You know, it started out as this like fun little side project, turned into many, many months of troubleshooting. You know, this thing isn't even particularly useful. Like a phone or a laptop could do way more than this thing could. I mostly just wanted to see if I could even do it. I've also always liked those e-ink displays. I just think they look so cool and it was a good excuse to learn how to use it. So I gave myself some design goals just to give me some direction, and mainly I wanted it to last a long time. Those e-ink displays don't consume much power and I wanted to kind of play off its strengths and kind of highlight that. And then I wanted it to be really portable, something kind of small and compact, something that would kind of fit in the palm of my hand. So at first I thought this thing would be pretty easy because it's literally just like a screen and a keyboard and a battery plugged into a Raspberry Pi. But it turned out to be way harder than that. You know, as part of that process, I learned a ton, way more than I thought I would about like Linux services and I2C, and I'm going to talk you through what I did. So to start off, I picked the heart of the computer. I decided to go with a Pi Zero format to get that really small form factor and really low power consumption. I was thinking about a Raspberry Pi, but I decided to buy an Orange Pi Zero 2W, mostly because it had a little bit more RAM than the Raspberry Pi, and it had USB-C ports. The Raspberry Pi Zero 2 still has micro USB, like it's 2015 or something. Now, one of the things that consumes the most power on a computer is the display. This is where e-ink comes in. If you haven't seen e-ink before, it only uses power when it changes pixels, so it uses way less power. And you get this really cool paper-like display. These WaveShare displays are super cheap and have pretty decent support. I decided to go with the 400 by 300 pixel display because I felt like that was a good balance of not too big, but not too small, and it matched the size of the Pi really well. Now, there are two ways to make electronics last longer. You could consume less power or just throw a really, really big battery in it. This battery is enormous. It's just huge. It's like 3 times bigger than the battery in my phone. With how low power the Orange Pi is, I think this will be a really good fit. Now, the last major component I needed was a keyboard. I did find this keyboard that's made by M5 Stack. It's really clicky, it's very tactile. I don't know if you can hear that. It feels pretty good. It feels pretty good in the hand. I just love that I have so many key options. To connect the battery to the system, I need to convert 3 volts to 5 volts. I found this clever little charging circuit on Amazon that has a built-in 5-volt regulator and supports USB-C charging. So the first roadblock I ran into was trying to get an operating system onto this Orange Pi. I struggled over and over. I kept getting compiling errors and kernel errors. Turns out that this Orange Pi is pretty picky about what type of SD card you use in it. Dug around in some forums and found that you need to use an A1 SD card. After I swapped out the card, it seems to run just fine now. So after I got an operating system on the Orange Pi and hooking it up to an HDMI display, I knew that it was working. Then it was time to start working on the e-ink display. So WaveShare, the maker of this e-ink screen, has some pretty well-documented drivers for Raspberry Pis. Turns out that the Orange Pi is quite a bit more different than I thought than the Raspberry Pi. While the pinout's pretty similar, the GPIO libraries are very different. I spent way too much time getting these stupid drivers to work. So it is like midnight right now, and working with this Orange Pi is just so frustrating. I'm having to basically rewrite the GPIO library from scratch, and it is driving me crazy. I just cannot get it to work. Like, I know I can output it to a pin, but it just, the library won't see those pins, and it is just driving me crazy. But after lots and lots and lots of troubleshooting, I was able to get something to turn up on this display. So it's one thing getting the screen to display the demo. It's another to get it doing something useful. In this case, I wanted to display like the terminal as if I had an HDMI screen plugged in. So what I do is I take my Orange Pi and then I spoof it into thinking I have an HDMI output. And I tell it that that output is 400 by 300. So that's the same pixel density. Wow, that looks like a 6. 400 by 300, the same pixel density as my, I'm going to call this e-ink. 400 by 300. So I tell it, hey, you have an HDMI screen. It doesn't actually have an HDMI screen. So it starts outputting images as if it were going to that screen into something called, I have a little bucket here called the frame buffer. So once images are in this frame buffer, as if they were going to like, a normal HDMI display, I take a Python script to grab those images from the frame buffer, convert them to black and white, and then display them over SBI to my e-ink screen. So then I can get what I want out of that e-ink screen. Quick update here. You can see here that I'm seeing the primary display. Right now I just have it refreshing every couple seconds. I need to update that to use the partial refresh, but I'd call this a huge win. Normally an HDMI output is going at 30 or 60 frames per second, but this e-ink display in fast mode can only display at 1 hertz, so 1 frame per second. Obviously that causes some limitations. Now one of the downsides of using fast refresh rate e-ink screens is that you get a lot of ghosting. You can still kind of see the previous things existing on the screen. Now to get rid of ghosting, the e-ink display has to periodically do a full refresh where it clears the entire screen of any images and then resets. On my custom service file, I baked in a full refresh to happen every couple minutes. I actually tied the built-in clear command that clears your terminal to also issue a full refresh. This feature I'm pretty proud of. Now that I had both the Pi and the screen working, all that was really left was to get the keyboard hooked up. Most stuff over I2C is really straightforward, but for some reason I was getting so much trouble with this keyboard. I just could not get it to work. I spent hours and hours and hours working. The worst part is it would just kind of work. I would see its address pop up and then go away. It would pop up, it would go away. It would work intermittently, which is super frustrating because it worked just enough to make me not want to start over or get a new keyboard. But it didn't work well enough to work. So I tried all sorts of different fixes. I tried shorter wires, I tried shielded wires, I tried pull-up resistors, and just none of that worked. After doing some troubleshooting, I decided to just plug the keyboard into something that I knew had working I2C drivers, and it worked on the first try, which told me that something was wrong with my Orange Pi. Turns out, after digging through some forums, that the Orange Pi 02W has some foibles with the I2C drivers, and oftentimes just doesn't work, at least on this specific board. And that really sucks, which that means that I need to essentially unsolder my screen, and I need to get a new operating system baked in, and I need to switch boards. And that means essentially starting from scratch. And for that, this thing can go to... So after ditching the Orange Pi, I decided to get the very well supported, bog standard Raspberry Pi 02. I was a little disappointed because I was looking forward to having USB-C and a little bit more RAM, but this thing just worked. I swapped in the Pi 02W and literally everything just worked. I reconnected the screen, used some of the built-in drivers, and I had the screen working way faster, partially because I understood what I was doing this time. I wired up the I2C keyboard and boom, worked on the first try. Sometimes going with the name brand really is worth it. Actually, I think the Orange Pi might have been more expensive. So here it is in all its glory. This, in essence, is the guts of the computer. All right, now we just got to pack this thing up in a way we can actually use it. So I booted up Fusion 360, took some rough measurements, and made some models of my of all the parts. I then catted up a custom case to fit everything together. I sliced it, threw it on my 3D printer. took a couple of attempts and it's not perfect, but before I knew it, I had a pretty decent assembly.
All right, so now we have to get all of this crap into this case. We can start off here by taking our battery. Should fit nice and snug right in there. Yeah, look at that. That's nice. Okay, now everything else is sort of soldered together, so all of that has to go into here all at once. So it's kind of a huge pain.
So I got the assembly started. I was pretty pleased with where the cable ports lined up and where the SD card port lined up. And actually everything fit in there pretty nicely. I was kind of surprised considering I didn't really put too much thought into how things would line up, especially the wiring. But overall, I was pretty pleased with how it all came together, especially the screw holes. Those lined up perfectly and held the computer down nicely. That power charging circuit and the power button went in really nicely. I wanted a really small bezel around the screen, and so I didn't have any screw mounts on the screen, and that was a bit of an issue. I had some screw mounts on the bottom, and that held the bottom half together really well, but because there was that really thin bezel along the top, it meant that I had lots of flex, and it didn't hold it down really well. And so I busted out the glue. What good engineering project isn't held together by glue? All right, that's it. It came together pretty well. A copious amount of glue here on the sides, but hey, it's pretty solid. It's got a nice weight to it. Even more glue. Oh yeah, glue for days, baby. So to turn it on, you just kind of click this red button here on the top. There are some kind of indicator LEDs here on the bottom that will light up to let you know that it's on. But you kind of just have to wait for the Linux boot up sequence. All right, so a moment of truth here. Let's see if this turns on. You know, the boot up time could be a little shorter. All right, let's go. Let's see if this all works. There's just enough lag that it's like not super comfy to type. But like, if you know you got it right. Boop. Okay. So we can clear all this. So running a clear command actually has a service file that wipes the screen here too. It totally works. Oh, it just feels so good. It's a little computer in your hand. I love it. So what can I do with this thing? Let's see. We can make sure that we have a network connection. Let's just ping 1.1.1.1. Oh yeah, there we go. The refresh rate's decent. Sweet, and it's actually nice because this I get the control key here. Yeah, function C, function X like control. So card KB, that's what I've got to run my keyboard. ePaper, that's what runs the screen, and then I've got projects. So let's enter the projects. Oh baby, look at that. Oh baby. Oh baby. Yeah, I could watch this all day. Somehow this with the low refresh rate just makes it so much more satisfying. Oh, look at that little face. Okay, that's amazing. This is amazing. So if I run the clear command again, you can see that left a lot of ghosting on our screen. So now we can just run a clear command and you'll see it do that full refresh. There we go, and we're back to the beginning. To turn it off, so you actually just press that twice. So one quirky thing about e-ink is if you turn it off, it just keeps displaying whatever it was displaying. So it kind of looks like it's on, but it's not. So I'm super pleased on how this turned out. I think it's a pretty sleek package. It fits in my pocket. It's not perfect. It's held together by lots of glue, hopes, dream, spit, everything short of duct tape. It's definitely never opening again, but for the most part, I'm really pleased. I think it turned out really well. You know, I like that there's not too much of a bezel around it. I really wanted to focus on the screen. It's kind of got like Game Boy vibes, right? Like classic Game Boy vibes. It's kind of about that same small, kind of shorter and fatter than a Game Boy. But it totally fits in my pocket, which is awesome. You know, looking back, I wish I had just picked a Raspberry Pi from the beginning. Even though it's not quite as nicely featured as the Orange Pi, I would have saved like weeks and weeks of work to just use the Raspberry Pi from the beginning. So looking back, what would I do differently? I think this keyboard is great. I love that it's fully functioned, but it doesn't look all that great. And the buttons are kind of tiny and a little hard to hit. Another thing about the keyboard is that if you push down in the corners, I didn't support it all that well. And so it kind of feels like you're pushing a button, but you're actually just bending the keyboard a little bit. You know, if I had a really nice resin printer, I think that would have turned out better. I could have sanded and finished this thing. But at this point, I'd already spent like months getting this thing even working. So the fact that it's working at all and is in a decent looking package makes me pretty happy. To wrap things up, I want to talk about my last design goal, which is battery life. I rigged up a little test where I just fully charged it and then just let it run until it died. Pretty simple. I did basically like 0 power optimizations on this. I left Wi-Fi on, I left Bluetooth on, I left it at a full clock speed, I left the screen refresh every 10 minutes. So this is a pretty worst case scenario, and it looks like it still lasted about 2 days, which I'm pretty pleased with. All right, guys, that about wraps things up. Let me know what you think of this thing in the comments. Is there something you want to see me run on it? Should I try and make it solar powered? Should I actually do some of those battery optimizations? Can it run Doom? Thanks, and I'll catch you in the next one.